All right, so this is chapter 4, section 2, triangle congruence by side, 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 and side, angle, side. I definitely want you to write down that you can prove that two triangles are congruent without having to show that all corresponding parts are congruent. Yay, that's the good news. Less work. And one of those ways that we're going to help save us some time is by the side, side, side postulate. If three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. Which congruent step are we leaving out by showing side, side, side? Which congruent step do we not have to even fuss with when we have all three sides? It is sufficient enough for all sides to be congruent. We don't have to show all the angles are congruent. So if AB is congruent to DE, EF is congruent to BC, and AC is congruent to DF, then triangle ABC is congruent to triangle DEF. All right, let's see how this applies to us in our real life. We are given that BC is congruent to BF, CD is congruent to FD, and we want to prove triangle BCD is congruent to triangle BFD. You know two pairs of sides that are congruent. What else do you need to prove the triangle is congruent by side, side, side? We need the third side. Congruent. And that happens to be BD. The triangles share side BD. All snuggled up against each other. Right here. BD. Complete the steps of the proof. BC is congruent to BF. It's given. CD is congruent to FD. That's also given. Reflexive property. You guys, what's the reflexive property again? I remember this because it's like a mirror. See your reflection. It's exactly equal property. It looks like a mirror. When an item is congruent to itself, it's reflexive. So BD congruent to BD. If you didn't know what the reflexive property was, you can always go to the references in the back of your book, and it has all the postulates and theorems written down back there for you. Triangle BCD is congruent to triangle BFD by side, side, side. All right, postulate 4-2, side, angle, side. We had side, side, side before. Now we have side, angle, side. If two sides and an included angle are congruent to two sides and an included angle of another triangle, then the two triangles are congruent. Let's see how this works out. So triangle DEF, that's this middle one right here. So DEF is this one right here, is congruent by side, angle, side. So we want, what other triangle, either AB or ABC or RST, which one has the angle congruent sign on it? It's this one. It's got the, it has this little T congruent sign on it. I can't use ABC because it gives me no information about its angles. So that is not going to work out side angle side. So triangle DEF is congruent to triangle, and I have to watch my order. T has the one with the angle, so that's going to go with T. E. Oh, T, I'm just an E. Is D. No. T is R. T, D and T are to go together. E and R. Thank you. And then S. By side angle side. That leaves us triangle ABC is going to be congruent to DFE, no, DEF by side. Please note, the angle has to be in between your two sides. So you see how this angle gets is adjacent to our two sides. It has to be in between the two in order to go side angle side. If he is on the outside of those sides, we can't use this property. All right, so we're going to use side angle side. What other information do you need to prove triangle LEB is congruent to triangle BNL by side angle side? All right, so circle the angles that are marked congruent in the diagram. So I have angle ELB and angle NBF. Circle the sides that form the angles that are marked congruent in the diagram. Circle the sides that form the angles that are marked congruent. Okay, so it's this side here, NB, or BN, and then his buddy, LB, and then that one up there, LE. So we are going to complete our congruent statements. Side LB is congruent to side LB. It's congruent to itself. That's a reflexive property. And angle BLE. BLE is congruent to LBN. Okay. Underline the correct words to complete the sentence. Proving triangle LEB is congruent to triangle BNL by side angle side requires two pairs of congruent sides, as evidenced by the S and the S, and one pair of congruent angles, as evidenced by the one angle in SAS. The diagram shows congruency of 0, 1, or 2 pairs of congruent sides. We actually have one pair of congruent angles. One pair of, we actually have 0 pair of congruent sides. Thank you very much. Just the diagram. So you're looking at this diagram without anything else marked on it. So I promise I won't mark anything. How many pairs of congruent sides do we have marked on this figure? 0. So we have no pairs of congruent sides. And how many pairs of congruent angles? Just 1. So, to prove that triangles are congruent by side angle side, we still need 2 pairs of congruent sides. And no pairs of congruent angles, because we already have it. to prove the triangle's congruent, you need to prove hold on, NB and EL congruent, because we can prove that LB is reflexive to LB, but we don't know anything about NB and LE. So let's make sure we circle BL on number 11. But it's not marked. Oh, circle the sides that form angles. Okay. Anything. Any other questions? All right, so identifying congruent triangles. When you use side, 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 or side, angle, side to prove triangles below congruent, explain. So let's complete these statements and see if we can explain what we would do here. Use which one? Side, 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 or side, angle, side for if you have 3 pairs of congruent sides? SSS. And use what if you have 2 pairs of sides and an included angle? The diagram shows congruence of 3 sides, true or false. And we're looking at this diagram here. The diagram shows congruence of 3 sides. Do we have all sides are congruent to each other? In the triangle on the left, the marked angle is the included angle of the side with 2 marks and the side with 3 marks. So is this angle in between the side with 2 marks and the side with 3 marks? True. In the triangle on the right, the marked angle is included angle of the side with 2 marks and the side with 3 marks. True or false? The angle is included in the side with 2 marks and the side with 3 marks. That's this angle. Is that the one that's marked? So which one should we use? Side, 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 or side, angle, side? So we're going to use side, 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 since side, angle, side would not work for the triangle on the right. True. So if we're looking at this figure right here, what other information do you need to prove triangle LEB is congruent to triangle BNL? All right, so we have the angles. We know LB is congruent to itself. We do not have NB and LE. So we need LE congruent to NB.